Okay, so this is a do now. You are going to get a piece of graph paper and you are going to graph first the two absolute value equations and then the two inequalities. So you can stop the video if you need to go get your graph paper. As soon as you get the graph paper, you're going to copy down all four equations and inequalities because I'm going to erase them soon. So copy them all down and try to graph these on your own. See if you remember how to graph them. If you really don't remember how to graph them, then you can just graph it as I do it along in the video. Once you're done, I want you to watch the video and make sure you graphed them correctly. Okay, so we're going to start off with number 1. So number 1 is an absolute value equation. Now, you didn't get to see me teaching this, but I want you to imagine me standing in front of the room with my arms upright, forming a V, like I'm a cheerleader. Absolute value, and I form a V. So an absolute value equation always forms a V, okay? So it's never going to look like a linear equation. Absolute value will always be a V. And at the bottom of the V is the vertex. And the way we get the vertex is we look at the number inside the absolute value with the X, and we do the opposite. And we look on the number on the outside, and that's your Y. So this vertex is -2, 3. The next thing you look at is you look at the number right in front of the absolute value sign. In this case, there is no number. And when we multiply and there is no number, it really is a 1. So that means in front of the absolute value is a 1/1. And the 1/1 stands for the rise and the run. So to graph this, I start at the vertex. So I go -2, -3. I rise, run, 1, run, 1. Rise 1, run 1. Rise 1, run 1. But I do that in both directions. And then I connect the dots and I have a V. Now, this particular one, the only type of transformation from the parent function here was that it translated, because instead of it having its vertex at the origin, the vertex is -2, -3. So this was a translation. Now, it's not a stretch, because to be a stretch, the number outside the absolute value would have to be greater than 1. 1 is not greater than 1. To be a shrink, it would have to be in between that multiplier 0 and 1. 1 is not in between 0 and 1. And to be a reflection, or for it to face upside down, the number in front would have to be negative. In this case, it wasn't negative, okay? So the only type of transformation that occurred was a translation. So now let's look at the next one. And number 2 was y equals 1/2 x minus 1 plus 2. So the first thing is I find the vertex. And the vertex is the opposite of what I see there and there. So my vertex is 1, 2. The number outside the absolute value is 1/2, which means I rise 1 when I run 2. So to graph this, I go to the vertex 1, 2. I go up 1 and over 2. Up 1 and over 2. Again, I go up 1 and over 2, up 1 and over 2. So this is wider because this is a shrink. This is a vertical shrink. A vertical shrink gets closer to the x-axis. Why did it shrink? It shrank because this number was in between 0 and 1. That made it shrink. Okay, and it's also a translation. Now, let's look at the next ones. The next ones are inequalities. So I hope you all watched the shaded video because I thought that really explained how to graph inequalities. So y is greater than -2x plus 5. So the first thing I'm going to do is I put a little dashed line here because this is not greater than or equal to, it's greater than. So I know that when I draw my line, it's going to be a dashed line. I also identify my B is 5 and my M is -2/1. So I start out by graphing the borderline, and the borderline is y equals -2x plus 5. So I go up 1, 2, 3, 4, 5, down 2/1, down 2/1, down 2/1, and I do a dashed line. Okay, so now I have to decide which side to shade. I'm either going to shade above or below the line. Well, a quick way of knowing where to shade it is you put your pencil right on the y-intercept and you say to yourself, where are my y values greater? Now, this only works if it's slope-intercept form. And so y values are greater up here. So that means I shade this side. Now, to test it, I test the point 0, 0. So 0, 0 is right here, and it should not work when I test it because it's not inside the solution set. So is 0 greater than -2 times 0 plus 5? Is 0 greater than 5? No. And that's good news because the side we shaded did not include 0, 0. So that means I shaded it correctly. Okay, now let's look at number 4. Number 4 is a little trickier because it's not in slope-intercept form. And I really encourage you to graph it by putting it in slope-intercept form. So -5y is less than or equal to -2x plus 10. Now I'm going to divide by a negative. And when we divide by a negative, we know we have to change the direction of our inequality sign. So y is greater than 2/5 x minus 2. Okay, so that means I go down 2 for my y-intercept, up 2/1, 2, 3, 4, 5. It's going to be a solid line because it's greater than or equal to. And now I just have to decide if I shade above or below. Well, it's greater. Where are the y values greater than my y-intercept? And they would be here. So that means when I test 0, 0, see if I'm right, it should be true. So when I plug in 2 times 0 is 0 minus 0, is that less than or equal to 10? Yes, it is. So 0, 0 is a solution, which means I graphed it correctly. Okay, so that's the end of this video.